idea that for well-behaved functions, can anyone tell me something that makes a function well-behaved? Never mind, tell me something that would make a function non-well-behaved. What would be a troublesome function? Division by zero, either a whole or a vertical asymptote. Division by zero could make a troublesome function. What else? Okay, imaginary numbers, that could be a troublesome function or a troublesome idea as well. So domain problems, division by zero, or imaginary numbers, or logarithms having to have positive arguments. No, sine's actually very well behaved. He just goes on forever, doesn't have any vertical asymptotes, no holes, no jumps. The other weird one would be a piecewise function. Piecewise functions, because didn't we see a piecewise function yesterday where it didn't meet up? It meaning the two branches at a point. It meaning the two guys headed to the diner trying to meet for breakfast. We saw this piecewise function that was non-well-behaved, had a limit that did not exist at a point. So to watch out for piecewise functions, PS, absolute value, is a piecewise function, right? But for well-behaved functions, we can just plug and chug. For well-behaved functions, we can just plug in where x is approaching and saying, oh, you're well-behaved, so the approach is going to equal the at. So if I find the at, I will know the approach. Yes, sir? Not sure if you'll be able to read it, bud. You got it? Okay. So the well-behaved functions. We were saying like, hey, instead of having to take this guy and plug him into our calculator and do 3.9 and 3.99 and 3.9999 and 4.1 and 4.01, 4.00001, plug in and say 4 squared is 16. We can just plug in and say square root of 9 is 3. We can just plug in and say 5 times 4 is 20. We can just plug in and say, this is where we were ending yesterday, pi cosine of pi. Pause. You're not done yet. What's cosine of pi? -1. Remember cosine's graph? At 0, cosine's at 1. At pi over 2, cosine's at 0. At pi, cosine's at -1. 3 pi over 2, cosine's at 0. 2 pi, cosine's at 1 again. Or you could think of pi as the point -1, 0. So I'm going to have pi times -1, which is negative pi. So maybe there's some math to be done when you're plugging in. Some trig to be done, but we got it. Speaking of trig to be done, what about the next guy? We skipped letter C, right? Don't we have tangent of pi over? No, wait. Tangent has vertical asymptotes. Tangent's not very well behaved. He has issues every... Where are his vertical asymptotes again? I've heard a lot of different things. Square root of 3 over 3, 1 square root of 3. 0, undefined, undefines at 90, or at pi over 2. Or when sine over cosine y over x would be undefined. But that's at pi over 2. So tangent is how would I say that? Is not very well behaved, is misbehaving. At pi over 2 and 3 pi over 2 and, but wait a minute, we're not at pi over 2. We're not at 3 pi over 2. We're at pi. Is tangent misbehaving at pi? No, he's fine. Oh, okay. So then plug in. 0 over pi is 0. So just because a function isn't well behaved everywhere doesn't mean that we can never plug into him. It just means that, okay, maybe we should avoid the problem spot. Or we'd have to do something special if we were at the problem spot at pi over 2. Life lessons. Anyway, letter F. What are we going to do for that one, guys? Yep, 7 squared is 49. So we have to watch out for those ones that have some trouble spots, or have some domain issues, or have some, for a piecewise function, some places where discontinuities can happen. But otherwise, we can just plug and chug. And that's what makes the beginning of limits, the basic limits, really fun, because it's literally just a plug and chug. This is called direct substitution. It's the first thing you should always try when solving limits by hand. When solving limits by hand is to solve the limit as x approaches c of f of x, plug in c. Or if you want to think x approaches a, plug in f of a. And as long as it's well behaved, as long as it works when you plug it in, you have your answer. So this is a homework-ish problem from last night. I don't know why it's not there. For some reason it disappeared. I don't think it was an actual homework problem though. Did you guys have one that was near 44? Ah, so I was trying to help out on those ones. So number 44 gives the following. Ooh, this is a party waiting to happen. It gives us the function f of x is equal to x over 3 minus x, and it gives us a second function, g of x is equal to sine of pi x, and then it asks us to do a few things. It asks us to try to think of, okay, the limit as x approaches 2 of f of x, the limit as x approaches 2 of g of x, the limit as x approaches 2 of f of x times g of x, and the limit as x approaches 2, I'm guessing, of f of x. Oh, nope, just kidding. Not what I thought they would do. G of x minus f of x. I don't know about you guys, but the symmetry is kind of throwing me off a little bit. Let's go ahead and make this a little bit prettier. It is 2. Why? Because you plugged it in? But wait a minute, this guy's really not very well behaved at 3. But where am I approaching? Oh, he's fine there. Okay, so I plug in 2 over 3 minus 2. Why am I not writing limit? Because I'm taking it. I don't have to write the limit anymore if I'm actually in process of solving it. So the limit has been taken. The approach is the at, because this function is well behaved at 2, well behaved basically anywhere but 3. So I plug in 2 over 1 is 2. Dun, 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 dun. Plug and chug. Now, what about letter B? Why? Because you're plugging in sine of pi times 2, which is sine of 2 pi, and sine of 2 pi, well, doesn't sine come right back to 0 at 2 pi? Good. Colby looks confused. Or you can think 2 pi. Oh, 1, 0. You weren't confused, sorry. So whether you think of the y being 0, whether you think of sine's height being 0 at 2 pi, either way. So how about letter C? What do you guys think? Technically, without using properties, you would have to think of, oh, stink, I have to take this guy, I need to multiply him by this guy. Okay, there's f times g. Now I have to plug in, but guys, notice, what happens when you go to plug in? Oh, it's the same thing as just 2 times 0, which is what our properties would say. It's just what our properties would say. So then, could we go ahead and take the g and take the f and plug them in and then go? Yes. Or we could just say, well, what's going to end up happening? You plug into g, and you plug into f. You can ultimately just say, oh, 0 minus, is that what you said, Thomas? Dun, 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 dun. What? Where it originated? I have no idea where it originated. Yeah, but like the actual tune that goes, I don't know. That's like the secret knock that everybody knows. But anyway, that's okay. Shoop, shoop. Any questions on homework from last night? Since we had a few things that kind of slowed us down at the beginning of class today, if you guys don't mind, maybe we'll check evens on Monday. But do you have any questions on odds? Patricia? 3 or 30? look at homework starting off rough. You create an open box from a square piece of material. You create a box. That's cool. Like fold stuff up. Anyway. Square piece of material is 24 centimeters on a side. You cut equal squares out from the sides, from the corners, and then you turn up the sides. Draw and label a diagram that represents the box. Okay. Hopefully for the box, it might be very helpful if I can get this out of your homework page. Hold on, give me a second. Let me snip it. Snip, snip, snip. Zoop. Okay. Box. You have your 24, what was it, 24 centimeters? You're cutting out, cutting out, cutting out, cutting out, when you're folding up. So you're taking that away, taking that away, taking that away, and taking that away. And these can have, we can have like x by x. They're squares, right? Side lengths x. Good. Draw and label a diagram. There he is. Write a function. Ooh, for volume? How do you do volume of a, it's not going to be a cube anymore. How are you going to do volume of a box? Base, area of the base, right? Times the height. So area of the base, isn't that just going to be, well, what's that going to be? I could do length times width times height. So I have V equals length times width times height. But here's the dilemma. It says V of, ooh, what variable do they want me to have inside? Wait. Isn't X how much you cut out? So who is that? Where's the cutout measurement? The height. Good. Because however much you cut is how high you're going to fold. Does that kind of make sense? So that's X. Well, what's these two guys going to be? 24 minus 2x. So I have to cut from here and here. So this 24 is going to be cut down 2x. So I'm going to have 24 minus 2x, and guess who else is 24? So I get to make 24 minus 2x, that guy also. So it's going to be V equals 24 minus 2x times x. We could multiply, we could simplify. There we go. The box has a maximum volume when x equals 4. If we were in calculus, we could be required to find that, but they're just telling it to us because we're not in calculus yet. Use a graphing utility to complete the table and observe the behavior of the function as x approaches 4. Oh. So who am I putting in my y1? That guy. What am I doing in my table? Plugging in. Oh, they did not even get very close. What about 4.0001 and 3.999? Party poopers. Anyway, they kind of approach, and then you're looking to see if it seems to, if the y or the volumes, the y values or the volume values, seem to be converging or approaching. And then it says to go ahead and graph the volume. To graph the volume. And it's probably something like this. That's typically what's going on. And double check that that maximum is at 4. And I believe when you find the maximum of that function, you will have a 4. Does that make sense? Okay. All right. Anything else that you want us to look at? Anybody? Ooh, some of us have some homework to do. All right. So let's go ahead and section 12.2. Ooh, hey, look. The answers. Let's not talk about that until Monday. Okay. Yeah. Well, because of all the stuff today, I said let's just grade quickly on Monday. So we'll grade evens first thing Monday. But technically, if you guys realize the evens are actually in your notes, so I suppose you could even grade the evens over the weekend. Or go to the video and pause the 2 pages I just skipped. Anyway. Yeah. Oh, you have a question? Yeah. On which one? 23. Oh, the piecewise one. That's a good one to have a question on. What were you thinking, Andrew, when you saw this one? Good. Okay, pause. when you said you drew the graph, you were using 2 as like your in-between, right? Like to the left and to the right. So then below 2, I'm hoping you did like one of these. Why am I doing a hole? It's not or equal to. And then I'm going to fill in this guy and this guy. Okay, well that's hard because we are used to graphing, right? Using this side of the graph I'm not supposed to be using. So you could actually like use the intercept and then go up 1 over 1, up 1 over 1. Like you could use this side, or you could technically just start at 2 and plug in. And plug in 2. 2 plus 3 is 5. 1, 2, 3, 4, 5. Oh. Huh. It fills it in. So this side came to a hole, but this side says, no, 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 2, 5 is an actual point. And then you go ahead and plug in 3. 3 will be 6. Up 1. Over 1, up 1, over 1. So here's the weird thing. There were 2 separate pieces. This one says, I'm going to a hole, and this guy said, no, 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 it's good, and fills it in. But if you're trying to find the limit as x approaches 2, actually whether or not that hole got filled in, because they're both headed to the same place, the limit exists. Whether or not it's filled in, whether or not it's opened or closed, they still headed to the same place, and that place is, plug it in, plug it in. Does that make sense? And the way that you can check it, remember, you can come from using our direct substitution thing. You could actually plug into the below piece. You could plug into the above piece. Remember, it's not about what is at the point. It's about the approach. And for the limit, we can just plug in. It's not which one is equal to, which one is not equal to. The point is where they're approaching. So when I plug in to this one, I would get 2 times 2 plus 1 is 5. When I plug into this one, which is the x plus 3, bless you, 2 plus 3 is 5. Since those match, the limit exists. Is that cool? Okay. Now no more questions for right now, right, on homework? Cool. Those of you that didn't finish up 12.1, you better have it finished on Monday. I'm feeling a spot check coming, but our job now is 12.2. Ooh! Solving limits by hand. We started that yesterday. Because we said you can just plug in. So why have a whole section? If they already told us you can just plug in, why have a whole section saying you can just plug in? This is the how to keep going if plugging in doesn't work right away. And this might be kind of what Joseph was doing yesterday with the factoring and the canceling and then the plugging in. Ooh, there are ways to keep going. There are ways to keep going. And Eileen, ready? For limits, when do you keep going? Indeterminate, and how do you know indeterminate? And a lot more that we won't go into right now. Okay, so 0 over 0 or infinity over infinity. You are able to keep going. Now, if you have number over 0, something more exciting is happening. Wait, 0 over 0 is a whole, usually. Number over 0 is a vertical asymptote, usually. Oh, the limits would be different for wholes than vertical asymptotes. Okay. So, 12.2, we're not dealing with vertical asymptotes, we're dealing with funny things that could happen when you try to plug in. So number 1 is still very valid. You have a limit, you're trying to solve it by hand, not with a graphing calculator, not with a graph. You always, 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 always try to plug in first. You always, always, always try to plug in first. If it works, great. If it works on a well-behaved function, great. If it doesn't work, haha, this is what the section is really about. If it doesn't work, haha, this is what the section is really about. So when I say strategies for finding the limit, Guys, this is not do step 1, then step 2, then step 3, then step 4. This is a do step 1, do step 1, try direct substitution, and if it does not work in a very specific way, then try, I don't know, let me give you some ideas. Try 2, or try 3, or try 4, or try 5. Worst comes to worst, all right, handicap, pull out your calculator, go to the table. If worst comes to worst, pull out your, I'm still an honors pre-cal handicap, pull out your calculator. Okay, so it's a try step 1, and then if it doesn't work, I don't know. Let's see, we have all these options of other things we can do. So, number 2. Number 1 has not worked. So I'm going to put a quick little, when plugging in results in, specifically for right now, we'll say 0 over 0, because when plugging in these functions in this section, you should not get yet infinity over infinity. So for right now, this section, my gets looks kind of funny. I don't know what it looks like. Gets? Anyway, something weird. When plugging in gets or results in 0 over 0, we're going to talk about this 0 over 0 a little bit more later on. It's technically called what Eileen said, indeterminate form. It's one type of indeterminate form. When plugging in gets 0 over 0, it didn't work. There was something misbehaving. It's a silly way of saying it, but something was misbehaving. All right, the first thing you can try. If direct substitution results in, well, that's silly. I guess I had it right here. 0 over 0. Yay, go team. Use factoring or polynomial division to simplify f of x, and that's what you guys saw Joseph do yesterday. Use factoring or polynomial division to simplify f of x. Are we ready yet? Can we go? Can we dual page it? Okay. First thing I want you guys to do, plug it in. Are you kidding me? No, I'm really, really not. Really, 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 really not. Plug in. Some of you are like, oh, but this is dumb because it's over 0. Let's just, no, plug in. When we plug in, what do you get? Yes, and because you get 0 over 0, number over 0 would be a very drastically different answer. 0 over 0 though, okay, then it's in this camp. And since it's in this camp, the first thing we try is, can we factor? And the answer is yes. Could we do polynomial division? And the answer is yes. Do we want to? Probably not. Because factoring hopefully is easier. So the limit as x approaches -3 of. Has anybody figured out the factors yet? Good. There's a hole at x equals -3. If I was rewriting the function, I could say this function is the exact same thing as x minus 2 for x not equal to -3. It's basically this line with a hole right there at -3. But for a limit, we can just say whatever. For a limit, we care about the approach. We don't care about the at anyway. We just want to know, where are you headed? And if we factor out the hole, we can know exactly where it's headed by plugging in. And so we factor out the discontinuity. We factor out the hole for the limit and say, hey, where were you headed? Well, you were headed at or towards -3 minus 2, which would equal -5. Do you notice when I kept writing limit and when I stopped writing limit? I stopped writing limit when I was trying to plug in. It didn't work. I kept writing limit because I still had to find it. I stopped writing limit once I solved. Does that make sense? Okay. Remember with that square root the other day, you can't just randomly stop writing it, or else technically you're wrong. So this is one version of 0 over 0. Hey, I want you guys to come over to this side. Ready? I want you to write, keep going. Did you guys notice when I asked Eileen, I was very specific about when do you keep going? Why? No, you didn't notice? I did. Why did I say keep going? because that's my key phrase. 0 over 0, keep going. Now, can you write keep going all the time? Nah, it's kind of long. So how about kg? Am I kidding about that? No. Do you have to write kg when you write 0 over 0? Yes. When do you write it? When you're plugging in, hoping it works and it doesn't work, and you remind yourself to keep going. How? Well, one way is to try factoring or try polynomial division. One way. But there are other ways that might also be helpful. Colby. If it's a long answer and you're writing me like a limit with its work, number one, you need to make sure that you keep rewriting the limit notation as long as is necessary, and you stop writing it once it's no longer necessary. And if it is an indeterminate form, that you first try plugging in, writing 0 over 0 with a little kg after it. This one. First thing you always try to plug in first. Plug in first. And when you plug in, what do you get? What are we going to write from now on? K, not KP. KG. Keep going. You're not done. 0 over 0 is not an answer. The function does not exist at 1. That is totally true. But the limit says, no, I don't care what's there. I care about, is there something it's approaching? X goes to 1. So, keep going. Now, some of you are like, psh, I can factor real good. Haha, the numerator. Got it done. Good. Use that mental math. Use that mental math. For the rest of you, you're like, it's a 4th degree. Okay, it's a 4th degree. Could you, if worst comes to very, 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 very worse, could you divide? Yes. And you would end up with x cubed. This is not going to be fun. X squared. X. One. Whoo! Then you could say, hey, I can rewrite this guy as the limit as x goes to 1 of x cubed plus x squared plus x plus 1. 1 plus 1 plus 1 plus 1, I did too many, equals 4. Done. And I didn't have to factor a thing. But for those of you that can factor, couldn't it have been nicer if we had thought, oh, couldn't x to the 4th minus 1 be a perfect, difference of squares? X squared minus 1, x squared plus 1? And couldn't we factor x squared minus 1 to be x plus 1, x minus 1? Then couldn't we, ha-ha, the over 0's gone, and he was the guy that made the problem up here. I've removed the whole, now let's plug in. The limit is gone because I am solving for the limit. I am taking the limit. And what is 1 plus 1? 2. And what's 1 squared plus 1? 2. And what's 2 times 2? Both ways worked. Both ways worked. But I do believe the factoring way, if you can get the factoring down, would be much easier. But does the polynomial division way work? Yes. You would just get right up here, 1 cubed plus 1 squared plus 1 plus 1, which is how I got my 4. Both ways work. Which is why 0 over 0, keep going. If you have a polynomial over a polynomial, try to factor. If you can't factor or you don't know how, divide. How we doing? All right. What if you get something nasty like this? This isn't a polynomial. I can't factor this guy. He's disgusting. Okay, then let's talk about a different way. If you have polynomial expressions, try factoring, try polynomial division. But if you have something with a square root, or even a cubed root, mostly a square root, with a radical. My advice would be to keep going, try rationalizing. My advice would be to keep going, try rationalizing, aka multiplying by the conjugate. Conjugate. Oh, that's a word from a long time ago. We used it in simplifying complex division. We used it in simplifying or rationalizing denominators with non-square root numbers plus or minus square root numbers. So how are we going to do it here? Conjugate. Let's say you have the square root of something. I don't even know what. We'll say u plus 1. If you're given, or if you have the square root of u plus 1, the conjugate is going to be the square root of u minus 1. And vice versa. If you're given the square root of u minus 1, the conjugate will be the square root of u plus 1. You're going to multiply top and bottom. So if we take this one, if we plug in, 0 plus 1 is 1, square root of 1 is 1, 1 minus 1 is 0. Plug in 0, 0. What are we going to do? Keep going. But how? Multiplying by the conjugate. So we're going to take this guy, the limit is still there. X approaches 0. Square root of x plus 1 minus 1 all over x. Where's my square root? Right there. What conjugate am I going to multiply by? The square rooty guy with an opposite sign. So the square root of x plus 1. Keep it the same. Keep the square root the same. Switch the sign in between. Aren't we going to have to FOIL the numerator? I mean, I guess we could leave it separate, but that's not going to help us out much. Quick trick. Keep the denominator factored. Because I'm really hoping this guy that made the 0 is going to factor out. So I'm going to leave him right where he is. And the numerator I'm going to FOIL. Since it's a difference of squares, the first one squared, square root times square root is just x plus 1. The outer and the inner will cancel, a positive square root minus a square root. And then I have the last, which is minus. X plus 1 minus 1? What happens? Ha! And as soon as the plus 1 minus 1 simplifies or cancels, now all of a sudden, what can I do with the x on top and on bottom? I can reduce. Ha-ha! And now the little guy that was making the 0 in the denominator just a second before is gone. And what can I do? The limit is gone because I am plugging in because nothing's going to stop me now. And I end up with 1 over 2. Do we know every single possible way of keeping going? No. But all we need to know is it's possible, and we'll keep learning and talking about it on Monday. All right, cool kids. Happy Friday. Happy weekend. Happy. Enjoy the heat outside and come by an ice pop at lunch for only $2. Sorry, the announcement didn't get changed. What was I supposed to do?